If you look at an old, like, ancient map of the world,
Mm.
you'll see these coastlines drawn in with just incredible meticulous detail.
Hmm.
But eventually, you scan toward the edge of the parchment, and the cartographer just draws a massive sea monster and writes, "Here be dragons."
Right.
It's an admission of ignorance. Is
Yeah,
the map maker basically saying, I have absolutely no idea what happens past this point, so I'm just going to draw a monster to cover it up.
yeah, exactly.
And when we talk about modern astrophysics, specifically the center of a black hole,
Hmm.
we have our own version of here be dragons. It's called singularity.
It is. And, according to Einstein's general relativity, that singularity is this point of infinite density where all of our beautifully elegant math simply crashes.
It's just a complete blank spot on the map of reality.
Absolutely. We know something massive is there, but the very equations we rely on to describe the curvature of the rest of the universe, they just fail catastrophically when we try to look inside that boundary. Over the last century, physicists have kind of just shrugged and accepted that singularity as a physical reality. But from a purely mathematical standpoint, it really functions as a fatal error message in the code of the universe.
Which brings us to the source material for your deep dive today.
Mm.
We are exploring a highly technical and, frankly, completely revolutionary manuscript
Right.
titled Transdimensional Unified Field Theory Version 3, or TBUFT,
Right.
and it's written by George James Dukas. The mission here is to unpack this incredibly dense theoretical physics paper because Dukas is making a massive, paradigm-shifting claim.
He really is.
He argues that the singularity isn't a physical reality at all. He actually calls it a mathematical pathology.
Yeah, a bug in the system.
Exactly. And to fix this bug in our physics, the paper proposes a completely new, parameter-free architecture for the entire universe.
Dukas completely throws out the standard Einsteinian smooth manifold that we're all used to. I mean, this is a radical departure from everything in the standard model. It rewrites our understanding of what a black hole actually is, literally from the inside out. And it replaces a continuous fabric of space-time with this quantized structured lattice.
And for you listening, I want to be totally upfront here. The math we're going to explore today gets heavy,
Very heavy.
but the philosophical implications are profound. If this theory holds up, it completely changes how you view space, time, and, well, matter itself.
Mm-hmm.
Consider this deep dive your shortcut to understanding the absolute cutting edge of fringe theoretical physics.
Yeah.
So, okay, let's unpack this.
Yeah, so before we can even look at what a black hole is in TDUFT, we really have to understand the canvas Dukas is painting on.
Okay.
He replaces empty spacetime with something he calls Phi Shell Architecture. The universe, according to this text, is an infinite, recursive, dimensional lattice made of spherical shells.
Wait, phi is in the golden ratio.
Exactly. That specific harmonic ratio dictates the spacing. So imagine every single particle, every atom, existing at the center of its own infinite set of concentric shells.
Oh, wow.
And Dukas divides this reality into two distinct regimes. First, you have the filled shells. These are the finite, localized shells close to the center specifically, shells 1 through 7.
Right.
And these contain matter. This is the stuff that makes up planets, stars, and, you and me.
And since they contain discrete matter, these filled shells follow the gravitational rules we already understand, right? Like the inverse square law, where gravity drops off by the square of the distance, or 1 over r squared.
Correct. But then, beyond those first 7 filled shells, you hit the empty shells.
Okay.
These radiate outward infinitely. They don't contain matter, but they form the actual vacuum backbone of the universe, which the author calls the D-lattice.
The D-lattice.
Yeah, and these empty shells follow a totally different mathematical rule. Instead of an inverse square field, they exhibit a 1 over r monopole behavior.
Right, and Dukas ties this together with a core dimensional identity equation, which is d to the 5th power equals mc squared. He describes this as a transmutative relation between mass energy and 5th power spatial extension, which honestly sounds like a mouthful of jargon.
It does a bit.
But mathematically, it basically suggests mass and space are fundamentally the exact same thing, just locked in different dimensional states.
Exactly.
But wait, hold on. I have to stop you there because I'm picturing this infinite set of Russian nesting dolls, or like the layers of an onion, extending out forever.
That's a good visual.
But if the vacuum of space is actually made of these literal infinite Phi shells, why don't we interact with them? Right? Why don't we crash into them? If space has a physical shell structure, Shouldn't we feel it when we launch a rocket? I mean, rockets don't crash into math.
Right, well, what's fascinating here is that you have to redefine what structure means in this context.
Okay.
These empty shells don't carry a gravitational field in the way a physical planet does. They carry entropy and geometry.
Huh.
Think of them as the degrees of freedom that allow matter to exist in the first place. They act as the background potential of the universe.
Oh, I see.
You don't feel them when you fly a rocket because they are the very coordinate space the rocket is moving through. The text argues the universe isn't some random, chaotic void. It is a precisely governed construct of infinite harmonic ratios.
So the empty shells provide this invisible geometric scaffold that allows the localized knot of matter to just, like, tie itself together.
Exactly.
Okay, so if the universe is literally full of these invisible structural shells, what happens when a massive star dies and that central structure buckles under its own immense weight? Does the harmonic lattice does it just break?
The lattice doesn't break, no. It reaches a limit. In this theory, a black hole is not a point of infinite density. It is defined as a shell collapse state.
A shell collapse state.
Right. It happens when all those filled shells, all that physical matter compress down and collapse perfectly into the radius of the empty shells.
And the paper describes this trigger mechanism as the horizon coincidence, right?
Yes, that's the term.
It says a black hole forms when three distinct horizons perfectly overlap. You have the coherent horizon, which is defended by the outward centrifugal force of the object's rotation. Then you have the fossil horizon, which is the non-rotating boundary. And when both of those perfectly align with the mass-defined Schwarzschild radius, the entire structure suddenly locks up, and boom, you get a shell collapse state.
Spot on. And this is where we see the stark contrast with general relativity. In Einstein's math, once you cross that event horizon, gravity curves space infinitely until all information is just crushed out of existence at the singularity.
Right, the infinite density point.
But in TDUFT, the interior of the black hole becomes a pure entropy limit. The paper represents this mathematically as the shell index, K, approaching infinity.
Right, and in plain English, K is just the number of shells on the lattice. So when the paper says K goes to infinity, it just means those Russian nesting dolls keep folding inward forever without ever hitting a solid center. I like to think about this like a software patch. A singularity in general relativity is basically a divide by zero error that crashes the universe's physics engine. TDUFT patches that bug.
That's a great way to put it.
But let me challenge this pure entropy idea for a second.
Sure.
How is a state where Duke goes to infinity any more physically real or, like, less confusing than a singularity? Aren't we just trading one infinite mathematical nightmare for another?
Well, no, because in general relativity, the infinity is breakdown. It means the equations literally stop functioning.
Okay.
But in TDUFT, this infinity is the natural calculated limit of the Phi Shell recursion. It's not an error message, it's the intended end of the mathematical sequence.
Oh, I see.
Dukas emphasizes that a black hole is a localized transdimensional knot in the infinite spatial lattice. It's not a rip in the fabric of space-time, it's a precise location where the geometric structure has folded in on itself to its absolute maximum limit, leaving a state of pure entropy securely contained within that specific boundary.
Okay, so the inside is a highly structured knot of pure entropy, which is completely different from a standard singularity. But if the interior of a black hole is vastly different in this theory, why do black holes still look and act exactly the same from the outside?
That is the million-dollar question.
Right, because telescopes observe them. We track stars orbiting them. Their external gravity behaves exactly the way Einstein predicted.
Reconciling the inside-outside discrepancy relies on a beautifully classic piece of physics, which is Newton's shell theorem.
Oh, wait, isn't that just the classic hollow Earth thought experiment?
Yes, exactly.
Like if you were somehow standing inside a perfectly hollow sphere that had the mass of the Earth, you wouldn't be pulled toward the edges. You would actually float completely weightlessly in the dead center because the gravitational pull from all sides of the sphere perfectly cancels itself out.
That hollow Earth concept is the perfect way to look at it because the paper applies that exact Newtonian mathematical theorem to those infinite empty Phi shells.
Okay, so because they surround...
Right, because they are empty shells encompassing the core, by Newton's theorem, they contribute zero net gravitational field to anything inside the radius. The gravitational forces of the infinite lattice seamlessly sum to zero.
leaving you with just the core mass of the collapsed filled shells in the center.
Exactly. The exterior field of this entire collapsed shell structure resolves into a pure 1 over R monopole potential. That mathematical output matches the exact Schwarzschild exterior we observe with standard black holes today.
See, here's where it gets really interesting, though.
Yeah.
We need to differentiate between this 1 over R potential and the 1 over R squared gravitational field without losing anyone in the math weeds.
Right.
If they're different mathematical behaviors, how does TDUFT perfectly mimic Einstein's field equations?
Well, potential, the 1 over R, is the underlying energy landscape.
Okay.
The field, the 1 over R squared, is the actual gravitational acceleration and object fields moving through that landscape. In calculus, the derivative, meaning the rate of change of the potential, gives you the field. What Dukas mathematically proves here is that taking the derivative of an infinite lattice of empty shells surrounding a collapsed core flawlessly mimics Einstein's math on the outside.
Wow.
Yeah. From the perspective of a telescope observing a star orbit a black hole, the gravity looks absolutely identical to general relativity. The external geometry curves exactly the same way, but the internal physical reality creating that curvature is entirely different.
Okay, so we've established this stable transdimensional knot. All the matter shells collapse contained by this boundary, with pure entropy roaring inside. But astrophysics tells us black holes aren't always static, permanent objects. This structure can critically fail. The paper talks about an explosion or a violent expansion event. What causes a locked transdimensional knot to suddenly blow up?
It comes down to a structural tipping point, which the paper calls the collapse to entropy threshold. Remember, there are two opposing forces at play in this localized knot. You have the structure of the remaining filled shells, which the paper labels mathematically with a C fraction, and you have the entropy of the empty shells pushing back, labeled with an S fraction.
Right. And the theory sets up an equation where the sum of the C structure fractions is divided by the sum of the is entropy fractions.
Yes.
And as that structure decays over eons, that ratio starts dropping. When that fraction approaches zero, the structure can no longer physically contain the interior entropy, and the whole D lattice just violently snaps outward.
Exactly. When geometric order effectively collapses to zero and wave disorder becomes everything, the localized system loses its structural integrity and blows outward, releasing all that contained energy back into the larger lattice.
So it's basically a balloon.
Yeah, that works.
The filled matter, shells, the structural C fractions, are the rubber of the balloon. The empty shells, the Ineos entropy, are the air pressure trapped inside. If the rubber gets stretched too thin as the structure decays and the internal pressure gets relatively too high, it just pops. It violently expands.
Perfect analogy.
But to mathematically explain this exact boundary threshold where the pop happens, the paper introduces something called the Eternum nexus equation.
Yes, it does.
And honestly, this part is incredibly trippy. It uses numbers, but it completely redefines how they function. It says 1 represents the geometric shell, -1 represents the wave or entropy support, and 0 and -0 define the boundary source itself.
Right.
It talks about squaring the circle to somehow create 1 from 0. I mean, using numbers like 1, -1, and -0, not as quantitative values, but as operator states. Isn't that just redefining basic arithmetic to force the theory to work?
Well, if we connect this to the bigger picture, it actually makes a profound kind of sense, especially when you look at quantum mechanics.
Really? How so?
In standard arithmetic, 0 is just nothing. -1 is a deficit. But in TDUFT, these aren't scalar numbers you use to balance a checkbook. They are representations of binary closure dynamics.
Okay, I'm listening.
Think of 0 as a perfectly calm, still lake. It's not nothing. It's a field of unmanifested potential. 1 is the waves peaking up above the surface, the resolved geometric closure forming an outward boundary. -1 is the trough dipping below the surface, its inward-turned wave entropy conjugate that structurally supports the peak.
Now the 0 and -0.
They represent the unresolved boundary potential of the lake itself before the disturbance. It's the origin point where geometry and wave aren't separately resolved yet.
Oh, wow.
So when Dukas talks about squaring the circle and creating 1 from 0, he's not claiming 0 plus something equals 1. He's demonstrating that a closed, coherent geometric form, the 1, emerges directly from that unresolved boundary potential, the 0. Form arises from the void.
And the Eternum nexus invariant equation governing all this mathematically equals pi squared, which the author calls a source invariant.
Exactly. Pi isn't just a measurement of a circle's circumference here. It's the foundational source code invariant that encodes the closure law of this entire binary substrate. When everything else collapses in the knot, Pi squared is the boundary constant that survives to dictate the geometry.
So we have this incredibly elegant, entirely new mathematical philosophy for how the universe functions at a quantum and cosmic scale.
We do.
But as anyone who follows theoretical physics knows, a theory is only as good as its predictive power. You can have the most beautiful, symmetrical math in the world, but if it doesn't match what we measure in reality, it's just science fiction.
That's the harsh truth of physics, yeah.
So let's pivot from the abstract math of the Eternum nexus to the hard, testable claims TDUFT makes against standard general relativity.
This is where the paper makes its absolute strongest stand. Dukas isn't just offering a philosophical interpretation, he's making zero-parameter, exact geometric predictions that already perfectly match observed data right here in our own solar system.
Yeah, the paper uses this Phi Shell harmonic geometry to calculate the exact distance of the heliopause, the outer boundary, where our sun's solar wind stops at exactly 120 astronomical units.
Which is spot on.
And it predicts Earth's magnetopause at exactly 10 Earth radii, no tweaking the variables to fit the data. The theory suggests that because our sun and Earth sit inside these harmonic shells, their energetic fields can only travel out to specific geometric boundaries before the background lattice forces them to stop.
Right.
And those purely mathematical boundaries land exactly on the numbers our probes have actually measured.
The ability to retrodict solar system boundaries purely from geometry is compelling. But the real test, what the paper explicitly calls the killer claim, is what this theory predicts we will see when we finally get high-resolution spectral data from the edge of a black hole.
Okay.
Standard general relativity predicts that the radiation emitted from the horizon of a black hole should be a continuous thermal continuum, just a smooth, featureless smear of heat radiation.
But TDUFT says something entirely different. It predicts that black holes should emit a discrete, Phi-modulated emission spectrum from the horizon.
Exactly.
And this is driven by geometric mode conversion as the knot couples to the surrounding lattice, rather than a literal material collapse emitting random heat. To put it simply, standard physics says the radiation signature should look like analog radiostatic, just a continuous hiss.
Yeah.
But this theory says if we listen closely enough, we should hear distinct digital stations, discrete emission lines, perfectly spaced out by that exact Phi ratio.
A completely discrete signature of the decaying structure fractions broadcasting their geometry out into space.
So what does this all mean? If this paper is perfectly predicting solar system data with zero parameters, and it's offering a perfectly clear, testable way to look at black holes with the Event Horizon Telescope, why isn't this front page news tomorrow? Like, what's the holdup on proving this?
Well, the holdup is entirely a technological limitation right now. Yeah, the theory is currently waiting on the spectral resolution capabilities of the Event Horizon Telescope Array to definitively prove whether those specific discrete emission lines exist. We literally just need better eyes to see the digital stations you mentioned.
That makes sense.
But Dukas makes it abundantly clear TDUFT is not just tweaking general relativity around the edges. It is aiming to entirely replace it. If those emission lines are detected, it proves a universal geometry that unifies nuclear magic numbers, the highly stable configurations of protons and neutrons inside atomic nuclei with cosmic event horizons.
Oh.
It proves that the very large and the very small operate on the exact same structural blueprint.
So let's synthesize this journey we've been on. We started by throwing out the empty trampoline of space-time and replacing it with an infinite lattice of recursive empty Phi shells. We explored how massive dying stars collapse not into a reality-breaking singularity, but into a transdimensional knot, a pure entropy state perfectly contained by a geometric boundary. We saw how Newton's classic shell theorem ensures this knot mathematically mimics an Einsteinian black hole to anyone looking at it from the outside. And finally, we look at how this entire radical framework could be proven true by finding distinct digital-like emissions radiating from that boundary.
It's a lot to take in.
It is. According to TDUFT, the universe is a harmonic unity. Dukas is essentially arguing that creation isn't something dropped into the universe that unfolds from the universe itself. It's the emergent localization of order within an infinite lattice.
It replaces a universe defined by stochastic emergence, randomness, chaos, and isolated phenomena with a deeply deterministic, harmonically governed architecture.
It really is a massive paradigm shift. And it leaves me with one final mind-bending thought to mull over for you listening at home. The text asserts that creation is an unfolding of shells. The system is literally an accordion of folding and unfolding geometry. So if you take that to its logical extreme, if the universe is an infinite, eternal geometric lattice, and matter is just an accordion of folding and unfolding shells, does the Big Bang even exist? Or was our entire visible universe just one massive, localized knot, simply untangling itself within a space that has always been and will always be perfectly harmonic?
It completely reframes our entire origin story. It suggests the map doesn't end at a single point in the past.
There are no dragons, just infinite beautiful geometry. Thank you so much for joining us on this deep dive into the source material. We hope it inspired you to keep questioning the physics of the universe around you. Keep looking up, and we'll catch you on the next one.